Hello, everyone. You're welcome to the first of my two-part series on how to Dockerize an existing web application or how to Dockerize a service and to deploy it to a Kubernetes cluster and also to put it under source control and also develop a rudimentary CI/CD pipeline for it to automate the deployment of the application, the continuous deployment of the application into a Kubernetes cluster running on Microsoft Azure. So we're going to go through the various steps involved in this, and we're going to start from the very scratch. I'm going to be using, let me look at the subscription to use. Okay, so I'm going to be using this subscription here, and we're going to put all our resources. There is an existing resource here, but we're going to be putting all our resources into a group, into a resource group. So let's go. So that's my folder here. We're going to be using this folder here, AKS calculator demo start. Okay, so let me grab demo start. Yeah, that's the one we'll be using. So I just want to grab the PowerShell script that we're going to start with and copy it over to the demo start. Okay. Right. So that's the PowerShell script. So let's go over to my Visual Studio Code. So let's go into. So this is the PowerShell script here. I'll give you a quick run through of the PowerShell script that we're going to use in creating our various resources on Microsoft Azure, and then we get into the business. So the first thing I do here is to set up a variable to something fairly unique. So I just put in something unique here. Definitely, I know this is going to be unique in the Azure world, just to avoid any conflict of any sort down there. So I call this Zodizotto. That's the name of a friend. Now, so we're going to set the resource group with a prefix RG. So it's going to be RG Zodizotto. We're using a location West Europe on Microsoft Azure. Then the container registry ACR will be ACR Zodizotto, and the Kubernetes cluster will be AKS Zodizotto. This is subscription ID that I'm going to be using. Then this is a Kubernetes version that we want to deploy into. And this is going to be the VM size, because the Kubernetes cluster is going to be creating a skill set, a virtual machine skill set. Please be sure to choose standard B2S. This is the cheapest range of VMs you can find, standard B2S. Anything more than this is going to blow out your free units subscription. And then the next thing is we're going to log into the account, log into the subscription, and set the context of to that subscription, because I got two subscriptions in the account. And then the next thing we're going to do is to create a resource group, and that will be using the PowerShell command here, new AZ resource group. The name will be Zodizotto and the location will be West Europe from here. Then after creating the resource group, we're going to delete any existing service principal file within locally to avoid any conflict when the cluster is being created, the Kubernetes cluster. And then the next thing we're going to do is to create an Azure container registry. So we already have our name ACR set up here. So that's going to be ACR Zodizotto. And yeah, set up here. So this is the resource group, and this is going to be the location, and we're going to use QBasic to save you some money, because this is a demo activity here. You can use the premium if you want to activate high-level security stuff on your container registry. And then just in case you don't have any SSH keys, you should generate them so that the cluster deployment statement can make use of it. I already have keys on my system, so I'm not going to bother to run this. And then this is the main deal here, and this is what's going to create the new Kubernetes cluster on Microsoft Azure. This is the name, AKS Auto. This is the location. This is a resource group. We're going to use a node count of 1. So that's 1 machine because it's a lot cheaper. For production environments, we recommend using a minimum of three machines, even for the smallest application. Then this is going to be the Kubernetes version, which we have described over there. And this is going to be the node VM size. And what this is going to do under the hood is going to create a service principal. And then after creating the service principal, it's going to then go ahead to create a cluster. Now, what's the use of the service principal? The use of it is that we're going to be communicating between the cluster and the registry. And the cluster needs to introduce itself to the registry, and it's going to do that through the use of a service principal, because the registry is not just going to let anyone pull an image out of itself. So the cluster is going to create a service principal, and at the same time when this is done, the service principal is going to be assigned a role on this cluster here, on the registry. And now what's the role is going to be assigned? Okay, we don't have it defined. So it's going to be assigned what we call a contributor role. That's a very powerful role for it to be able to get images out of the container registry. And the next thing we're going to do is to grab the credentials from the cluster that we've just created so that we can run kubectl commands against the cluster. So in a nutshell, that's what the PowerShell script is all about. Nothing fancy, nothing complicated. So we're going to run this in batches. So we're going to run this whole bunch of lines right now, run selection. And there it's run successfully. You can see it there. And then the next thing we're going to do is to try log on to Azure and be sure that we are using these subscription. So we run this. So it's going to give us a code that we're going to use in logging in. So we need to go on to the browser. So we chuck the code in, say next, then log in using the subscription. Then it says we should cancel. Yeah, so it's all fine and dandy now. So we are in the subscription and we're sure that we're in the subscription. That's a subscription there. And the next thing we're going to do is to create a resource group. A resource group, run selection. So new resource group RG created, and we need to verify that. Let's go into, let's go in here, subscriptions. Let's go in here and resource groups. And RD and going to it is empty, no resource to display in RG Auto. So it's been created. So let's go back now. So the next thing we're going to do is delete any existing service principal. And then we're going to create a container registry. Now the container registry, the Azure Container Registry, is the place where we're going to store our Docker images within Microsoft Azure. Like I said, I already have SSH keys, so I won't bother creating them. Then the next thing we're going to do, this is the major one, is going to take about 10 to 15 minutes to complete. But we're going to keep busy within that time, and we're going to have a look at the little application that we're planning to Dockerize and deploy into a Kubernetes cluster. So we're going to start with this. I must warn you that this is going to initially come back with an error. The reason is that it's going to try to create a service principal. Now, it takes time for Microsoft Azure to propagate the creation of that service principal across the various resources. And this command is going to try to go ahead to use that service principal and is not going to find it. So I must warn you ahead that we're going to get 1 or 2 errors first before we get it right. So let's run. So you can see it says no service principal found. And now it's trying to create it. It's trying to assign it and to create it, creating a new service principal. So it's already created it. It's trying to add the role assignment, but it cannot do it. So it's going to keep trying. If we're fortunate enough, it will find it before it times out. If it doesn't find it, it will error out, and then we repeat the command. Yep, it looks like we're doing okay. It looks like it found it, and we're good to go. So while this is going to take a little while to run, let's have a look. Let's see what's going on the browser. Let's see what's going on the browser. Let's refresh RGs or Risotto. So you can see here, this is the container registry here. The Azure container registry is being created. There's no repository inside it, all empty, no image or anything inside it. And then let's go to the cluster. So this is the Kubernetes cluster. It's busy creating it at the moment. And you can see total cores 2, total memory 4. And let's see, node pools. Let's go to the node pools. So you can see node count 1. That was what we specified with a node size of standard B2S. So it's not going to cost us too much money. And this is the namespace that it's using. So we let that run. We'll let that keep running. And let's go back into into our business here. So the next thing we're going to do is to examine an application that we want to Dockerize and deploy to the Kubernetes cluster and see what we need to do. So I'm going to go into this where I have stored my artifacts and copy across the source code and an Azure CLI script that we're going to be using. So let's go over to demo start and then paste it there. So, and let's then go to Visual Studio Code. So Visual Studio Code has it. Oh, one more thing I need to copy across. Okay, I'll do that later. So this is the application that we want to Dockerize. And I'll give you a run through of this application while our cluster is being created. Now, I've called the application AKS calculator. It's just a rudimentary calculator, and it does only one thing: add 2 numbers and return the result. And we're going to have a look at it. So this is the solution here. This is the project here. And this is the controller. It's a service. So if you come in here, this is the AKS calculator controller deriving from controller base. All right, let's grab some dependencies here. And then this is the call that it exposes. Add 2 numbers, input 1 and input 2. And then it returns the result via JSON. So what does it do? It presses these 2 strings to get number 1 and number 2, adds them up together, wraps them up in an await, pretending to be busy, though it's just a simple addition, and then logs the information out to whoever cares to know. Now, if for any reason this fails, maybe like you're supplying a dodgy string, it's going to fall into this exception block, and it's going to grab the message and set it up as the result. So this is a response object. Now, what's the response object? The response object has only one thing to do: to present a result. It's a POCO result, and we've applied a JSON property here to make sure that we get lowercase field names on the JSON. So that, once again, that's the controller, and it's a very simple application. It's a service, and we're going to run that. And also what I've done is to wrap what you call a Swagger template around it. So with a Swagger template, let's do something here. Let's call this AKS calculator API. So implementation of AKS calculator. Okay. in ASP.NET Core Web API. So it is ASP.NET Core. These are my Twitter handles, and okay, so everything looks fine now. So the next thing we want to do is we will now attempt to build and run this application in Visual Studio Code. In Visual Studio Code, we're going to attempt to build and run it. So let's see, ls. Okay, so let's go into the source folder, ls again, so that's the folder AKS calculator. All right, so we can see the solution now and the project. So let's do .NET. Okay, let's do .NET build and see if that works. So what it's doing here is that it's restoring the NuGet packages for the project. So it's all built and run. Let's see if we can run it. .NET run. Oh, okay, so because the project is in an inner folder, so we're going to --, project, and see // AKS calculator. Yeah, if that doesn't work, we'll add one more to it. Oh, okay, it does. So it's telling us now that the application is listening to us on 50729. So let's see if we can get this to work. Ooh, AKS calculator API. You see? So we have this call here. So you see, this is what the Swagger template gives us. It gives us a nice little interface that we can use in interacting with the service. It's like a service discovery mechanism. Okay, so let's put number 5 and number 6 here. 5 and 6 execute, and it gives us a nice little JSON here. Result is equal to 11. So we are sure that this service works. So what's the port number again? 50729. Then I have got my Postman here, 50729, and I've set up a little test here. So let's look for an environment, 50729. Let's clone these up. 50729, 50729, and then let's come over here, 50729, and then update this, and then close it. So select 50729, and then let's run this. Add 2 valid numbers, add 2 and 2. So the result is equal to 4. And what I've done also is that I've written a few tests. So I'm testing that we get a code 200 back. I'm testing that we get a field name result. And I'm also testing that the answer is 4. So, and it runs very well. All 3 passes. And then let's go to adding 2 invalid numbers, 2 and Bob. That's not supposed to work. So input string was not in a correct format. And I set up some tests to verify that. Code 200, body matches result. We have the result showing up in this string. And then the result is equal to input string was not in a correct format. So that's fine. So these 2 tests are working. And then we have what you call a runner here. And what the runner does is to run the suite of tests. So AKS calculator demo, and then you pick the environment in which you're going to run 50729, and it runs all the tests. So 6 tests and all passed. So we're going to be using Postman to test our results. So let's say, okay, collection runner. So let's go back to, oh, and we've got some nice little logs here. See, the 5, 6, and 11 gave us some login here. 2 plus 2 and 4 gave us some login here. And then we put in some dodgy characters. See, crap info sent through to and Bob. If you look into the application here, let's see, where is the controller? Crap info sent through. So we're trapping all the exceptions, and then putting a message through. So you see, crap info sent through to and Bob. Crap info sent through to and Bob. You see. So we've got some nice little login going on the terminal here in the background. Now let's see how far we've gone with our Kubernetes cluster. Hooray! New Azure Kubernetes service cluster is created. So we're ready to go. Now the next thing we're going to do is, now that we're sure that our Kubernetes cluster is running on the browser, we then want to bring in Docker into the mix. So this is what I've done. We've got the solution and the project running all fine on the command line. So I think we can just go ahead and stop the application. So shut down the application now. So let's look into the Docker file. So I have a nice little Docker file here. And what the Docker file does is to bring in the SDK image from the hub, and then it's going to copy the solution into a work directory called app that is created on an image that we want to produce. And then we're going to copy the project file as well, csproj, into this folder here. And then we're going to run a .NET restore. So this is going to restore this to the NuGet package is concerned with this too. Now we're going to copy everything else. By everything else, I mean this entire project here. And the next thing we're going to do is we're going to build, do a release build, and then we're going to copy. We're going to copy into the out folder, and then we're going to define an entry point. And what this does is that whenever this image is run in a container, is going to run the .NET. Okay, and it's going to bring the .NET runtime here. So we're not going to use the SDK. We're going to use just the runtime. So we have a very light image being built. And then it's going to copy these out into the app AKS calculator out folder. And then it will do the .NET run to start up the website or to start up the web application. So very simple Docker file, and this is what it does. And we're going to go, so I have an Azure CLI script here, and what this Azure CLI script does is to build an image that has the name logion /AKS calculator using the Docker file that we just examined here. And then what's gonna do, and then it's going to build it and put it in our local Docker repository. And then it's going to spin up 3 instances of that same image in 3 different containers and assign 3 different port numbers, 8081, 8082, 8083. So let's watch this run. So we can just do this and run line in terminal. So you can see it chugging away now. The Docker image is being built. The Docker file commands are being processed one after the other. See, from the SDK, and then it created a work dir app. It's copied the solution across. It's copied the project file across, and then it's doing the .NET restore, and then it's done this copy command, and then it's done the .NET publish, which also we do some NuGet package restore again, and then it's gone all the way. Boom. So we're done. So what this has done is that it's wrapped up, this process has wrapped up this application in an image called logion AKS calculator. So if you run docker image ls, you can see it here, Logion AKS calculator, and the tag is called latest. It created that 24 seconds ago. Now these are what we call containers. So there are 3 containers here running the same image, right? As in running a distinct copy of the same image. Now the beauty of this is that you can get this, various instances of this image to run on the same machine. So here am I on my MacBook Pro. I've got 3 instances of this website running very easily. Now you only get that with containerization. Now if you were to do this before containerization, you probably need a bunch of VMs, to provide a self-contained environment for each of these to run. In the meantime, let's quickly test. Let's do a quick test of this web applications. So this is it again, AKS calculator demo, and we're going to go into 8081. In fact, let's just go straight to the runner so we don't waste too much time. So we'll go straight into the runner. We're going to run these 2 tests, and we're going to specify the environment 8081. You see, all 6 tests passed. And then we're going to go into the runner again. Run the one for 8082. All 6 tests passed. And then we're going to go into 8083. Run this again. All 6 tests passed. So that's how we're going to be testing our deployments. We're going to use Postman to test all our deployments and make sure that our websites are running fine. And if you come over here, if you really insist on seeing the front end, 8081, see, running fine. 8082, running fine. And 8083, running fine as well. So this is what Docker gives you straight out of the box. Now let's go back into Visual Studio Code. So we are sure that we have these 3 applications running, and we're good to go. Now the other thing I'm going to do, so I think I want to stop this. Let's go into the dashboard and stop all 3 applications from running, and then just remove them from the local container registry. Okay, so we're done with that. And the other thing I have is what I call the Docker Compose file. And what the Docker Compose file, it's going to call the Docker file here to do this build, and then assign the deployment to port 5006 on my machine, and create a custom network called front, and then hook it up here. Now the reason for the compose is that later on in subsequent recordings, we're going to be having multiple solutions that are going to be built with Docker Compose, because this Docker file, we're only just going to use it for one solution. So each solution is going to have its own Docker file, and the Docker Compose is going to compile and start up the applications, multiple applications. So that's what the Docker Compose will do. So we just kept the Docker Compose here with the single project here, but we're going to need it later on. Now that we're sure that we can run this locally with Visual Studio Code, we can run it through a Docker hub, local Docker hub container. The next thing we want to do is to deploy these applications into the Azure Container Registry. And I've prepared an Azure CLI script for that. So this is what we have here. So we've already logged on to this subscription, so I don't think we need to do this. So this is what we're going to be doing. We're going to be deploying this image, AKS calculator, to ACR Zotto. In fact, that should be Zodi Zotto. We almost missed that. So this is the name of the registry on Microsoft Azure, ACR Zodi Zotto, and using this Docker file. And we need to be sure that we're in the right directory where that Docker file exists. Yeah, this one. So let's give it a spin and see if we can deploy this into the Azure Container Registry. So let's go. Oh yeah, it's doing that right now at the moment. So what we're doing now is we've instructed the Azure Container Registry to grab the source code from our machine and build the application into an image using the instructions in this Docker file, and then deploy the image into itself, which is the container. So once this is done, we're going to have a look at the registry to see what we have. Okay, so let's see how we're doing for time. Okay, we're just about 31 minutes. Okay, so the build is going on here. Still going on. While that is chugging away, let's go over to PowerShell. Now that our cluster is ready, there's one more thing we need to do, which is to grab the credentials, the kubectl credentials, so we can interact with the Kubernetes cluster that's just been created for us. So that's done. kubectl get service. So we see here that our AKS is running, Azure Kubernetes service is running. So that's it there. Let's see, get pods. No resources found. We don't have any deployment yet. Get deployment. So nothing yet. So let's see what's going on with Azure Container Registry. So this has been deployed successfully to the Container Registry. Let's have a look in Microsoft Azure. Let's go to the Container Registry. Let's go to repositories. Boom, AKS calculator is already deployed. Version 1 tag 4:40 a.m., 4:41 a.m. You see, so it's all working fine. So the next thing we need to do is then do something, create something, or create a link between the container registry and the Kubernetes cluster. Our eventual destination is the Kubernetes cluster. We want to build an application, push it into the container registry, which we have just done manually, and then instruct the Kubernetes cluster to pull that image from the Azure Container Registry and deploy it into itself. So that's the next thing we're going to do. So we're going to copy some resources across, and that is the manifests that we've got here. So we're going to copy this manifest across. Copy manifests. So we're going to this manifest. So this is what we call a YAML, and I've combined two regions into this one single file. The first one is the deployment YAML, and what the deployment YAML instructs Kubernetes to do is to deploy this service here. So we're going to be deploying a load balancer called AKS calculator. and we're going to be deploying it. We're going to be grabbing the image for it from ACR Zodizotto, and this is AKS calculator v1, which we just saw on the Kubernetes, on Microsoft Azure. And then what this script is going to do rather is going to instruct Kubernetes to go into the Azure Container Registry to grab this image, AKS calculator, and deploy it into itself as a service using 2 replicas, as in deploy it to 2 pods. So each pod is going to be running a container of that image. So let's go for it. So ls, let's move over to the root folder. Okay, so let's do an ls. Okay, so we've got the manifest here. So you just issue the command kubectl apply -f, which means the file, -f, and then we're going to do a dot manifest, and then we're going to use AKS calculator dot YAML. So kubectl apply -f AKS calculator dot YAML. So let's have a go at this. So it comes back straight away, created. And what this is going to go off to do, this has instructed our AKS cluster, Kubernetes, to go into Azure Container Registry to pull that image out and deploy it onto itself. So how do we know that it's done the job for us? Let's do kubectl get pods. Can we find that command? Okay, we can't. So let's kubectl get pods. So the first one is running, the other one is container creating. So yeah, so both of them are running. So let's do get service. So it's created a load balancer for us, AKS cluster load balancer. So we're waiting for an external IP address so we can we'll be able to connect. So we can be able to connect to the deployment. So let's give it one more try. Yeah, still going. All right, let's do get deployment. Get deployment, so tells us that we've got 2 running there. Let's see if we've got the IP address. Okay, we're still trying to get the IP address of the deployed service. So Kubernetes has gone into the Azure Container Registry to grab the image and deploy it into itself, and is deployed 2 instances of it across 2 pods. So you see, this is the first pod, this is the second pod, and this is it here. Another interesting thing is replica set. Get replica set. So this AKS replica set 2. So it means that we got 2 VMs. We got 2 replicas of that image running on our cluster. So that's what it means. Let's see if we have an IP address now. Okay, still chugging away for the IP address. So let's go into Kubernetes here to see what's going on. RG Zodizotto, say Kubernetes. So this is a node pool here. We have a node pool of one node count. You see that? And so that's, see if there are any more interesting things to look at. Networking. Let's go to the networking. So these are the IP addresses in use. And oh yes, there was something I was going to show you. Let's go into the container registry and go to the access control and then go into the role assignments. You can see that for free, it's created something for us called AKS Zodizotto app. Now, what this is, this was the service principal being created when we were deploying the cluster. And what this service principal is doing is that it's being presented as the identity of the cluster so that it can have access to ACR Zodizotto to pull that image. So that's why it's got the contributor permission. So AKS Zodizotto, and you see that, yep. So you can see that here. Let's see if we have our IP address now. We still don't have the IP address yet, so we'll just be patient a little bit. So we have our container registry up and running. We're pushing directly to it from the command line. We have our Kubernetes cluster up and running. We're talking to it directly from the command line using kubectl. We've instructed Kubernetes to deploy images, to deploy an image, that's pull it from the container registry and deploy 2 instances of itself, of that image onto itself. So that is running fine. So we just need to grab the IP address for that deployment. So we're still waiting for this IP address to come through. Wow, it's about 4 minutes since it was deployed now. Get pods. Get pods. Yeah, the pods are still running. Get replica set, still running. Get deployment. Yeah. Yes, we have our external IP address. So let's grab this external IP address and let's go over. Yeah. So if we plug that into the browser, then we're going to see our service run. See, that's the service running. Yeah, there's some latency because that was the first time, but you see, it can be very quick. So we can test the service again. So let's try it out using the Swagger template. 5 and 5, execute. We should get 10 back. You see, that result is equal to 10. And then we can take that into, let's see, into our environment here. Let's call these, okay, let's duplicate this. Calculator. Let's call this default because we're using the default namespace. And then let's put in the IP address, yeah? Oh, sorry, yeah. Yeah, that's the IP address, and let us update. And then let's go away. So calc default. And then let's run it. Oh, something went wrong. Let's see. Let's look at the environment again. Calc default. So that's the IP address. AKS calculator. Let's take that out. Yeah, so it's running now. All passed. So we can then go into our collection, our runner. So what the runner will do for us is to run the entire suite of tests. And let's go to calc default, run. So 6, all tests passed. So that's our deployment working. And we have our deployment sitting on the AKS cluster. So please join me on the second video where we're going to deploy these entire application into DevOps Azure, so we can set up a CI, an automated CI/CD pipeline for a dev build. And what this is going to do for us, I mean, you see how long it took us to deploy things from one place to the other. We first of all had to deploy the image manually to Azure Container Registry, and then we also deployed it manually to Kubernetes cluster, instructing Kubernetes to pick it up from Azure Container Registry and deploy it onto itself. So on the next video, what we're going to do is automate this process. We're going to get a CI/CD pipeline on DevOps Azure to automate this process for us and automate this build process, this deployment process for us. It's going to do a build, it's going to push it, label it, and push it into the Azure Container Registry. And then from the Azure Container Registry to pull the image and deploy it onto Kubernetes. And we're going to be making use of namespaces as well on the Kubernetes cluster. So I hope you enjoyed this video. You've learned something. And also, this is the PowerShell script that we used in creating our resources on Microsoft Azure. The resources are still going to be running onto the second and the third video, where we're going to be creating our automated CI and CD pipelines. And also, when this demo is done, I'm going to stick up the source code into GitHub, where everyone can pull it down from and have a play with it, and the PowerShell scripts as well. So thanks for watching, and make sure you join me on the second installment of this walkthrough. Thank you very much. Bye for now.